Hello, today I'll be presenting my literature review for cognitive science. Um, it's titled AI Assisted Programming Cognitive Impacts on Novice Learning. Modern AI accepts natural language and returns complete solutions for programming problems. Students are already using it extensively, but educators don't know whether to prohibit or to enable the use of AI. The key question is, are we eliminating an inefficiency or eliminating learning itself? Traditional web searching looked slow. Students spend 19 to 28% of their time searching, but it also embedded crucial cognitive processes that resulted in students building schemas. In my research design, I conducted a three-phase literature review. First, I established the theoretical frameworks in cognitive load theory and metacognition theory. Second, I examined how programmers learn traditionally to establish a baseline. Third, I analyzed current research on how students actually use AI and which interaction designs preserve learning. Brandt found programmers had two help-seeking modes. 78% were quick reminders, so this could be legitimately cognitive offloading that AI should optimize. But 22% were learning mode, where this would look like looking up tutorials and query refinement, and this is where problem decomposition and other useful skills are learned by software engineers. So this maps onto a 60-40 split. So 40% was friction that AI should indeed eliminate, but 60% was essential cognitive processing that builds expertise. In my key result number 2, we found that cognitive load theory generates two predictions for the advent of AI. So optimistically, AI reduces extraneous load, so this looked like no more filtering through Stack Overflow, but freeing working memory for understanding. But pessimistically, AI eliminates germane load, so this looks like the effortful processing that builds schemas. When AI generates complete solutions, students skip tracing code execution and chunking patterns. They also bypass the metacognitive cycle, which includes planning, monitoring, and reflection. So, in current evidence, the bad news is students default to copy pasting, and explanations alone do not help. They actually develop false confidence in the AI. But in good news, interaction design can overcome these bad outcomes. Studies show that forcing students to attempt answers before seeing AI suggestions increases learning. And surprisingly, giving explanations without complete answers produces more learning than giving both. In conclusion, interaction design is the key that determines learning outcomes. AI isn't inherently good or bad for learning. Three principles emerge. First, we should use indirect scaffolding, like hints and questions and not complete code. And we should also require engagement before assistance. So students must attempt solutions before seeing AI. And third, we must be context aware. We must optimize the 78% reminding mode with instant answers, but scaffold the 22% learning mode with engagement requirements. So to summarize in one sentence, AI can either eliminate learning or enhance it. It's the interaction design that determines which.